Hey everyone, and welcome to our lesson on electrical charge. So by the end of this lesson, you should be able to summarize static and current electricity. So first, let's just make sure we understand the electricity deals with the flow of electrons. So charge itself is defined as a basic property of protons and electrons. If you remember, protons are positive, electrons are negative. And because they have opposite charges, they actually will exert a force of attraction. So basically, um, basically, like attracts an opposite charge. So protons and electrons are attracted to each other. You'll also see that they have forces of repulsion, which we're going to discuss about like charges pushing away from each other. So two positives will push away from each other, two negatives will push away from each other. So just remember, attraction, they come close together. If they're oppositely charged, repulsion, they push away from each other. So now let's discuss static electricity, which is the accumulation of charges on an object. So you guys, you've all done the experiment where you rub a balloon like against your hair and you pull it off and then your hair's all staticky. And this is where we have a charged object that can cause electrons to rearrange their position on a neutral object, which then, will cause a force to be exerted. This can be caused by rubbing two objects together, so exposing an object to friction. And you can also see this defined as induction. So induction is the rearranging of electrons on a neutral object caused by a charged object rubbing against it. So if you've ever seen, you can take a spoon and you can rub it with steel wool or like a sock or something, and then you hold it against a flow of water, it'll cause the water to bend. That is an accumulation of charge. So an electric field is an area over which an electric charge exerts a force, and it exerts a force on anything that has an electric charge. So there has to be something with an electric charge present to have that field applied. And it's strongest near the electron and will become weaker as the distance between the object and the electrons are increasing. The further apart they are, the weaker it is. So electricity, as we've talked about with electric charge, we're looking now into conductors. And you should know a little bit about conductors. Metals are great conductors. And these are materials that allow electrons to move very easily through them. And metals are good conductors because, if you remember, they have the sea of electrons in terms of their model. They're free floating, so they're able to move more easily. We also have materials that are called insulators, and these do not allow electrons to flow easily. These would be like rubbers, plastics, wood, which is why a lot of your wiring is wrapped in some sort of plastic or rubber coating so that the wires are not exposed, since they transfer energy so easily. And then we have grounded objects, and these are connected to the earth or the ground by a good conductor. An electroscope is an instrument that can detect an electric charge, so they can be used especially during storms when lightning is present. And lightning is an extremely large discharge of static electricity, which causes, the flashes in the sky.